Okay, a couple of definitions. So we've got some function f that's defined over some interval, and c is a number inside that interval, some x value. Then we say f has an absolute or global maximum. I'm going to use those terms interchangeably. Absolute maximum, global maximum at the value x equals c if that y value is bigger than all the other values in the interval, bigger than or equal to. And we say we have an absolute or global minimum at C. That's the location of it. If that's the smallest value in the interval, smallest y value, less than or equal to. Okay, so this guy here, he's defined for all real numbers. He has no absolute maximum or minimum. He goes up forever, it goes down forever. This guy here, also defined for all real numbers. So my interval here that we're talking about is negative infinity to infinity. He has an absolute maximum at x equals 0. That's the location. When we talk about these global and local max and mins, these extrema, we want two pieces of information. Where does it occur and what is the value? Where is the x value? What is the y value? Write that down. Where is the x value? What is the y value? This has an absolute maximum at x equals 0. That's where it occurs. What is the absolute maximum? What's the highest y value? 1. So this has an absolute max of 1 at 0. I'm going to write that. So absolute max of 1, meaning the y value, at 0. That's the x value. Of is the y, at is the x. This guy has no absolute minimum because he keeps getting closer and closer to 0, but he never touches it. There's no one spot I can point to and go, that's the lowest value, because I can always find one lower. So this guy has no global minimum. Okay. What about cosine? What's the biggest value cosine reaches? 1. But it reaches 1 an infinite number of times. At every value that's a multiple of 2 pi. So here, that's right, that is right there, that's 2 pi. And then if we keep going over here at 4 pi. And those are supposed to be the same height. Now, this is weird. We say we have an absolute maximum if that y value is bigger than or equal to all the other y values. So that's an absolute maximum, but so is that, and so is that, and all of them are. You can have more than one global max if they reach the same value. So this guy has an infinite number of global maxes at all the 2 pi's. He has global mins at all the odd pi's, 1 pi, 3 pi, 5 pi. Those are all the absolute or global mins. Okay. Let's look at this graph here. The absolute maximum is the highest point that exists on the graph. That is right there. So we have global, I'm going to write it, global max of 2 at 0. That's my y value. That's where it's located, the x value. That's the biggest value anywhere on my domain. What's the minimum? How low does this go? Well, it tries to get down to -2, but there's nothing there. So there's no y value I can point to and go, that's the lowest value we ever reach. If you would say -1.99, I can go a little bit lower than that. Negative 1.999999. I can go a little bit lower. This guy has no global minimum. It wants to be -2, but there's not a solid dot there. Look at this guy. What's his maximum value? It's right there, 4 at 4. The value is 4 and it occurs at x equals 4. That's the biggest value. What's the minimum? There is, remember, see how I wrote, or I didn't write it, but somebody put the solid dot there and a solid dot there. We only emphasize those at endpoints where there's some ambiguity. All of these other points are solid dots. That's a solid dot. That's a solid dot. It's like Oprah. Everybody gets a car. These are all solid dots. There is a solid dot right there. If there weren't, somebody would have put an open circle. So what's the lowest value? 0. That's my y value. Where does that occur? At x equals 2. That's my x value. This guy has a global min. The smallest it ever gets is 0. That occurs at 0. But he does not have a global maximum, because this goes on and on forever. It never reaches some highest y value that's bigger than all the other y values. So there's no guarantee that you're going to have global maxes and mins, and there's no guarantee they could be unique. We could have a constant function. Let's say y equals 3. On this constant function, this is weird, every single point is a global max. Every point is a global max because every point is greater than or equal to every other point. And every point is a global or absolute min, because every point is the lowest we ever reach. So you can have an infinite number of global maxes and mins. You might have one, you might have none. If I had a graph that looked like this with an open circle and an open circle, this guy has no globals at all, max or min. That wants to be the lowest point, but there's nothing there. That wants to be the highest point, but there's nothing there. Okay, that's a good place to stop here.